Welcome to this explainer. I'm really thrilled you're here today. We are going to step straight into the mindset of a senior engineer to fundamentally elevate your API testing workflow. Look, if you've been using Postman simply as a point-and-click request builder, you're honestly barely scratching the surface of what it can do. Today, we're going to transform it into a highly sophisticated hub for API governance and automated orchestration. Let's get into it.
Let's be totally honest for a second. Are you still manually copying and pasting expiring OAuth tokens every 60 minutes? Have you ever completely lost your train of thought while debugging just because your token suddenly expired? It's literally exhausting, right? Manual handling of authentication tokens is a huge source of friction in API testing. When we hardcode URLs or just paste raw tokens directly into our requests, we're creating these brittle, error-prone setups. It slows us down, causes false negatives, and frankly, it's just a headache we don't need. To get us out of this messy cycle, we're going to hit 5 key things today: the hardcoding trap, Postman variable scopes, managing dev, staging, and prod environments, automating authentication, and finally, we'll walk through a real-world payment API fix. All right, part 1, the problem with hardcoding. Okay, let's dive into this. Pasting raw URLs and credentials directly into your requests? Sure, it might work for a super quick one-off test, but it's honestly a junior mistake that simply doesn't scale. Think about a hard-coded request for a second. You've got the raw domain, the hard-coded endpoint, and this giant text block for a bearer token. If that token expires or you suddenly need to test against localhost instead of production, you have to manually edit that whole string. No way. Instead, we want to replace that static text with double curly braces. Things like base URL and auth token. This is dynamic syntax. It's a simple abstraction, but it means your request is no longer tied to one single environment or some temporary secret. It becomes reusable, clean, and totally professional. Moving right along to part 2, Postman variable scopes explained. To make those double curly braces actually work, we need a really robust variable framework. Managing state and configuration across the whole API lifecycle depends entirely on understanding variable hierarchies, or what we call scopes. Variable scope is basically the execution hierarchy that Postman uses to figure out exactly which specific value to inject into your request. When a request is executed, the sandbox environment looks at the context, resolving everything from the absolute broadest available scope down to the narrowest. So let's actually walk down this hierarchy. At the very top, we've got global variables. These are for broad, cross-workspace utilities, but you definitely want to use them sparingly. Next down are collection variables, which apply to specific folders or functional groups. Then we have environment variables, and these are tied to your specific stage, like dev or prod. Below that are data variables, which are used temporarily during collection runs with external files. And finally, at the very bottom, the narrowest scope, local variables. These are temporary states that live only inside your scripts for the duration of the request. The golden rule to remember here: if 2 variables share the exact same name, the narrower scope always wins. A local variable will override a global variable every single time. And hey, since we're talking about variables, we absolutely have to talk about security. As the Postman documentation strictly points out, you should never, ever leak secrets to the cloud. Postman uses what's called a local-first architecture. This means you keep your sensitive secrets, like your personal API keys, in your local values or the Postman vault. You only commit shared values to a Git repository or sync them up to the team workspace. Doing this ensures your local workbench stays a safe space for experimentation without risking some massive security breach. Okay, part 3, managing dev, staging, and prod. Now that we've got a handle on variables and their scopes, let's see how environments actually leverage these variables to seamlessly isolate the different stages of your software lifecycle. The big thing to notice is how the variable names, the keys, like base URL and API key, stay exactly the same whether you're in dev, staging, or prod. It's literally only the value that changes. Your dev base URL might be localhost, while your prod base URL is the live API. Because the keys are identical, you don't have to change a single character in your actual request. The environment you happen to have selected is what dictates which values get injected at runtime. Setting this up is incredibly straightforward using the environment dropdown in the UI. But let me give you 2 senior tips to really level this up. First, use environment colors. Set your production environment to red and your dev environment to green. That visual cue literally prevents you from accidentally running a destructive test against live production data. Second, use type-safe inputs. You can actually define validation rules for your variables, so a variable that's supposed to be an integer port number can't accidentally get populated with a string. Which brings us to part 4, automating auth with scripts. Let's see how we can build on this to completely eliminate manual token pasting. The absolute secret weapon here is the pre-request script. This is just JavaScript code that Postman automatically executes before your primary API request is fired off. And here's the best part. You don't just apply this to a single request. You apply it at the collection level. When you do that, every single request inside that entire collection instantly inherits the automation. Let's break down the logic of this script methodically. We obviously don't want to blindly request a new token every single time we hit send. That would totally flood the auth provider and we'd probably get rate limited. So, step 1. We parse the existing token from our variables and read its exact expiration time. Step 2. We compare that expiry to the current time. If and only if the token is actually expired, we hit the auth endpoint to grab a new one. Step 3, we save that fresh access token right back into our collection variables so all our subsequent requests can just use it. To make step 2 happen, we rely on a very specific function from the Postman sandbox, pm.sendRequesting. This is an asynchronous background method. It basically allows your script to reach out to the identity provider, do the whole OAuth dance, grab the new token, and set it up. And it does all of this completely headlessly, right before your actual primary API request goes over the wire. Now, why go through all this trouble? Well, this automation isn't just about saving you a few mouse clicks on your laptop. It is absolutely critical for headless testing in CI/CD pipelines. When your tests are running automatically out on a GitHub Actions runner or a Jenkins server, there's obviously no human sitting there to manually fetch and paste a token. Your Postman collections have to be fully self-sufficient. All right, bringing it all together with part 5, a real-world payment API fix. Let's anchor all of these concepts, variables, environments, and automated auth, into a real day-to-day survival scenario. Imagine this. A critical support ticket just drops. The pet store payment endpoint is completely failing in production. Your adrenaline spikes. But right now, your Postman is configured for local development on localhost. A junior developer might completely panic, duplicate the request tab, manually type out the production URL, hunt down a production auth token, and probably make a typo in the process. But not you. You've got that senior mindset. You don't rewrite anything. You calmly execute 3 steps. 1, you hit the environment selector. 2, you switch from dev to production, and immediately you notice the UI banner turns bright red, giving you that visual confirmation you're handling live data. 3, you just click send on the exact same request tab you were already using. And this brilliantly illustrates the power of what we've built today. Without altering a single line of code, your base URL variable instantly shifted from localhost to api.petstore.com. On top of that, because you switched environments, your collection-level pre-request script immediately noticed you didn't have a valid production token. It silently executed pm.sendRequest right there in the background, fetched a secure prod token, and injected it into the header. All of that happened in the split second after you clicked send. It's just perfect harmony between environments and scripting. By taking the time to really understand variable scopes, properly leveraging your environments, and utilizing those pre-request scripts, you've essentially transformed API testing from a brittle, annoying chore into a highly robust, scalable engineering practice. So now that you have the tools to eliminate hard-coded chaos entirely, I've got to leave you with this question. Which manual, repetitive workflow in your API integrations are you going to automate next? Thank you so much for watching this explainer, and happy building!